Okay, I've written 3 quadratics up on the board. I want you to factor and find the roots of each of these quadratics. So pull out a piece of paper. You don't need to turn this in. On that paper, use the box, factor each one of these quadratics. Once you factor them, then find the roots. And go ahead and pause the video, and when you're done, we'll go over the answers. Okay, so to factor these, right, the box, we put in x squared and 16. Times those together, 16x squared. What are the factors of 16 to add to be negative 10? Negative 8x and negative 2x, which gives me x minus 8 minus 2. Set those equal to 0, and I get x equals 8 and 2. Hopefully, you're getting really good at this, because you're going to need it for the remainder of this year and next year. For the next one, x squared and 9. X squared times 9 is 9x squared. Are there factors of 9x squared that add to be 6x? And they are 3x and 3x. So, pull out an x. X times x is x squared. This is plus 3. That's plus 3. And my roots are x equals negative 3. And the other root is also negative 3. So we don't need to write it twice. Something similar happens on the last one. X squared and 25. Multiply those together. 25x squared. So are the factors of 25x squared that add to be negative 10? Would be negative 5x and negative 5x. So x times what is negative 5x. Same thing happens over here. My factors are the same. Set it equal to 0. X equals negative 5. Once again, I have the same root twice. And we're going to focus on this situation where the factors are the same. Where you have a quadratic and you factor it and you get 2 factors that are identical. So over here we have x minus 5 and x minus 5. One way to write this is x plus 3 times x plus 3. Or if you're lazy like me, you could write it as x plus 3 to the second. And the next one would be x minus 5 to the second. So for the next couple days, we're going to focus on quadratics that factor into 2 identical factors, which means the same root happens twice. So you still need to know how to factor this kind, but we're going to ignore this for a while. And if you look closely, you notice a pattern. So over here I've written x plus 3 squared. And maybe let me get rid of all of this. So we had x squared plus 6x plus 9. And that turned into x plus 3 to the second. The other one was x squared minus 10x plus 25. And it factored into x minus 5 squared. Now, the pattern we want to look at is, how does this factor compare to that number and that number? And similarly, on the other side, how does this factor compare to that number and that number? And you'll notice that the middle term is actually 2 times the root, or the factor 3. And that's true over here on this other side. The middle term is 2 times negative 5. And that's a pattern we're going to use today. And the last term happens to be the end term in the factor squared. So if your factor is x plus 3, the middle term is 3 times 2. It's double the 3, 6. The last term is 3 squared, which is 9. And the same holds true over here. If my factor is x minus 5, then the end term is going to be negative 5 times itself, which is 25. So any time a single root happens twice, you're going to get factors that are identical, and those factors are going to create quadratics that have very specific patterns. So today, we are going to be looking at quadratics that are incomplete. For instance, x squared plus 8x, and then there's some unknown variable here. And it's usually we stick a c out there. And it wants to know what number has to go there if a factor is something x plus something to the second. Well, if you remember the pattern, I had x squared plus 6x plus 9, and that factored into x plus 3 squared. The relationship between this number and that number is the middle term is twice as big as the factor. So if I know that the middle term is 8, then the factor would have to be 4. Well, if the factor is 4, then what would this number be? And the answer is, over here on this right side, if the factor is 3, how do we create the 9? And the answer is we square it. It's 3 squared. So 4 squared is going to be 16. So if the middle number is 8, then the end number would have to be 16 in order to factor like this. Now, if the answer was something else, if C was, say, 7, it would still work. X squared plus 8x plus 7 factors into x plus 1 and x plus 7, which is nice to use, but remember, it's not the same factor. Those two factors are different. So let's try another one. X squared plus 24x plus c. And if you look at the top of your assignment, it's asking for completing the square. What that means is, what number goes here so that when it factors into a perfect square. So it's really easy to do. You take the middle number and you divide it by 2. So x plus 12 is the factor. Well, if the factor is plus 12, then the c value is going to be 12 times 12, 144. Now, this might seem super easy, and it kind of is today. It's going to get a little bit harder. But when the middle number is odd, it's a little bit more difficult. So let's say we had x squared plus 11x plus c. Well, my recommendation is never, ever use decimals when you're completing the square. Fractions are much easier to use. So this is going to factor into x plus something to the second, and that something that goes here is half as big as the 11. So you could say 5.5 or 5.5. Don't write it that way. Just say 11 over 2, which is 5.5. But tomorrow when we move on, if you use the decimals, it's going to be very difficult to get the right answer. So now, what number can I create from this to complete the square? And the answer is 11 squared over 2 squared, which is 121 over 4. That's the number that will complete the square. Okay, so if I had x squared plus 20x plus c, what number would complete the square? Well, x plus 10 is the factor, and then 10 times 10, c equals 100. Okay, if I had x squared plus 1x plus c, or we usually don't even put the 1 there, x squared plus x plus c. This one's a little bit hard. It's going to be x plus half of what's there. Well, the number that's there is 1, and half of 1 is 1/2. So if 1/2 is the factor, then 1/2 times itself is the constant. So 1 squared over 2 squared. 1 times 1 is 1, and 2 times 2 is 4. The answer is 1/4. Okay? If I had x squared plus 30, well, let's not make it that big. X squared plus 17x plus c. The factor will be x plus 17 over 2. And then we need to square this. Well, it's going to be 17 squared over 2 squared. So it's something over 4. If I type in 17 squared, I get 289. So 289 over 4 is the number we're looking for. Now this isn't going to make a lot of sense until we go further into it. All we're doing is practicing completing the square. Every once in a while you'll run into one that's a fraction already. For instance, x squared plus 7/5 x plus c. Well, how do you cut a fraction in half? The easiest way to cut a fraction in half is to double the denominator. So the fraction right now is 7 over 5. If I want to cut that fraction in half, I change it from 7 over 5 to 7 over 10. So this would be x plus 7 over 10 squared. So 7 squared is 49 over 10 squared is 100. That is the number that completes the square. So let me do one more fraction. X squared plus 9 20ths x plus c. So I need to factor it. X plus, well, half of 9 20ths is going to be 9 40ths. And I'm going to square that to get my c value. 9 times 9 is 81. 40 times 40 is 1600. So 81 over 1600 is the answer. So today should be pretty simple. Take the middle number, cut it in half, square that number, and that will complete the square. Good luck.